What if I told you that the gasoline inside your car was once a thick black liquid that looked more like tar than fuel? It sounds impossible, but every gallon of gasoline begins its life as crude oil, a messy mixture of hundreds of different chemicals pulled from deep underground. Yet somehow, giant refineries can separate, crack, heat, transform, and rebuild those molecules into the clear fuel that powers modern vehicles. And here's what makes it even crazier. The refinery responsible for this transformation is so large that it often looks like an entire city of pipes, towers, furnaces, and storage tanks.
Let's go inside one of the most complex manufacturing processes on Earth and find out. The journey begins thousands of feet beneath the Earth's surface. Deep underground, crude oil is trapped inside porous rock formations that were created millions of years ago. Oil companies drill wells into these formations and use powerful pumping systems to bring the crude oil to the surface. Every day, millions of barrels of crude oil are extracted around the world and transported to refineries through pipelines, rail cars, and tracks. When the crude oil finally arrives at a refinery, it doesn't look anything like gasoline. It is thick, dark, sticky, and filled with hundreds of different hydrocarbon molecules. Some of these molecules can become gasoline. Others can become diesel fuel, jet fuel, lubricants, asphalt, plastics, and many other products. The challenge is separating and transforming them into useful materials. But before the refining process can begin, the crude oil must be inspected. Laboratory technicians collect samples and analyze the oil's chemical composition. They check density, sulfur content, water contamination, and various other characteristics. This information helps refinery operators determine exactly how the crude oil should be processed. Once approved, the crude oil enters one of the first major stages of refining, the desalting unit. This may not sound exciting, but it is extremely important. Crude oil often contains salt, dirt, sand, and water that can damage refinery equipment. Inside the desalting system, water and electrical fields help separate these contaminants from the oil. The impurities are removed, leaving cleaner crude oil ready for processing. Now comes the first dramatic transformation. The cleaned crude oil enters giant furnaces where temperatures rise to around 350 to 400 degrees Celsius. The heat is intense. At these temperatures, much of the crude oil turns into a mixture of hot liquid and vapor. And this is where things get interesting. The heated mixture is sent into one of the most recognizable structures in any refinery, the fractional distillation tower. These towers can be hundreds of feet tall and are often visible from miles away. Inside the tower, something remarkable happens. The different hydrocarbon molecules begin separating based on their boiling points. The lightest molecules rise toward the top of the tower, while heavier molecules remain lower down. Think of it like sorting hundreds of different ingredients using only heat. Near the top, refinery gases are collected. Slightly lower, gasoline-producing components begin separating out. Further down, kerosene and jet fuel fractions are removed. Even lower, diesel fuel is collected. The heaviest materials remain near the bottom. At first glance, it may seem like the refinery has already produced gasoline, but not quite. The material coming from the distillation tower still doesn't have the quality required for modern engines. In fact, much of it needs further processing before it can become finished gasoline. This brings us to one of the most important parts of the entire refinery: catalytic cracking. Large hydrocarbon molecules are often too heavy to be useful as gasoline, so refinery engineers use special units to break them apart. Inside catalytic cracking units, extremely hot hydrocarbons come into contact with powdered catalysts. These catalysts help split large molecules into smaller and more valuable ones. And here's the amazing part. This process can dramatically increase the amount of gasoline a refinery produces. Without catalytic cracking, modern fuel production would be far less efficient. As the cracking process continues, more gasoline-producing molecules are created, but the refinery isn't finished yet. Some hydrocarbons are routed to hydrocracking units. These systems use hydrogen, pressure, heat, and catalysts to create additional high-quality fuel components. Other streams move into reforming units. The purpose of reforming is to improve gasoline quality.
Inside these units, hydrocarbon molecules are rearranged into more desirable structures. This increases octane levels and improves engine performance. Octane is extremely important because it helps prevent engine knocking and allows fuel to burn more efficiently. And this is where gasoline begins looking less like a refinery byproduct and more like a finished fuel. But surprisingly, there still isn't one single gasoline product. Instead, the refinery now has multiple gasoline components produced by different processing units. Each component has unique characteristics. Some have high octane, some improve combustion, some enhance cold weather performance, others help meet environmental standards. Now comes one of the most carefully controlled stages in the refinery: blending. Think of this process as creating the perfect recipe. Engineers use sophisticated computer systems to combine different gasoline components in precise proportions. Every gallon must meet strict specifications for performance, emissions, volatility, and quality. Even small changes can affect how the fuel performs inside an engine. During blending, additives are introduced as well. These additives may help clean fuel injectors, reduce engine deposits, prevent corrosion, improve storage stability, and enhance performance. Different fuel brands often use different additive packages, which is why companies advertise their proprietary fuel technologies. At this stage, the gasoline is very close to completion. But before it can leave the refinery, it must survive one final challenge: quality control.
Samples from every batch are sent to laboratories for testing. Technicians analyze octane ratings, sulfur levels, density, vapor pressure, chemical composition, and overall performance characteristics. If a batch fails any requirement, adjustments must be made before distribution. Only approved gasoline is allowed to move forward. The finished fuel is pumped into enormous storage tanks. Some of these tanks hold millions of gallons of gasoline at a time. From there, the fuel enters one of the largest transportation networks in the world. Pipelines transport gasoline hundreds or even thousands of miles across the country. Other shipments move by tanker truck, rail car, or marine vessel.
Eventually, the gasoline arrives at distribution terminals. Here, additional brand-specific additives may be mixed into the fuel before final delivery. The gasoline is then loaded into tanker trucks and transported directly to gas stations. Within days, the crude oil that arrived as a thick black liquid has been transformed into a highly engineered fuel capable of powering modern vehicles. And that's the part most people never see. Behind every gallon of gasoline lies a massive industrial operation involving drilling rigs, pipelines, desalting units, giant furnaces, distillation towers, cracking systems, reformers, blending equipment, laboratories, storage facilities, and transportation networks.
So the next time you stop at a gas station and fill your tank, remember that the fuel entering your vehicle has already completed an incredible journey. It traveled from deep underground reservoirs to some of the largest industrial facilities on Earth before finally reaching your car. And that is how gasoline is made. If you enjoyed this behind-the-scenes refinery journey, make sure to like this video, share it with your friends, and subscribe to the channel for more amazing manufacturing stories from around the world. Also, don't forget to press the bell icon so you never miss our next video. Thanks for watching, and we'll see you in the next one.